Welcome to The Explainer. Today, we're diving into one of the internet's first big existential crises. It was a battle over digital real estate that honestly could have stopped the internet's growth dead in its tracks.
I mean, really think about it for a second. You type in a website, hit enter, and boom, in less than a second, you're connected to a server that could be thousands of miles away. How in the world does your computer know where to go? Well, it's not magic. It all comes down to having the right address.
And this is really the story of that original address system, and how its incredibly rigid design created a catastrophic flaw that almost brought the whole internet to a screeching halt.
Okay, so to really get the crisis, we first have to peek inside the internet's original address book. What even is an internet address anyway?
You see, every single device on a network, your phone, your laptop, it actually has two different addresses. There's the MAC address, which is like a permanent serial number baked right into the hardware. But the one we care about for surfing the web is the IP address. It's better to think of that one like your home address. It's a logical location that tells the rest of the world where you are right now.
So this original system was called IPv4, and it was all built on a 32-bit number. Now, this number wasn't just random, it was smart. It created a hierarchy, a structure, that let data get routed efficiently from one place to another. It was really the foundation of order for the early internet.
But here's the thing about that hierarchy. It was organized into this really rigid structure. The folks who designed it created what's called a class system to put every single address on the internet into a neat little box. So what they did was they chopped up that 32-bit number into different sections. The first few bits told you the class, and that decided how the rest of the bits were split up between a network ID or net ID and a host ID for all the individual computers and devices on that network.
Now, this system gave you just three main options. You had Class A for a tiny number of absolutely enormous networks. Then you had Class C for tons and tons of very small networks. And sitting right there in the middle was Class B, which was kind of the go-to for medium to large companies. The other two, D and E, were just kept aside for special uses.
The best way to think about it is with a mailing address. The net ID is like the zip code. It gets the data to the right neighborhood or network. Once it's there, the host ID is like the street number, pointing to the exact house or device. It's simple, right? Yeah, unfortunately, that beautiful simplicity was also its fatal flaw.
And this is where that rigid system started to cause a full-blown crisis. The internet was exploding in popularity, and this whole class-based way of doing things was leading to an unbelievable amount of waste.
As the source material says, the internet was barreling towards a dearth of IP addresses. I mean, they were literally running out. And not because there weren't enough numbers to go around, but because they were being handed out in these huge, inefficient chunks.
Get a load of this number, about 64,000. That's how many unique addresses you got if you were assigned a single Class B network block, which, remember, was the most popular choice for any decent-sized organization.
And here it is, the heart of the problem. A university or a company might need, maybe 500 addresses. But to get them, they had to ask for a Class B block, which gave them 64,000. So what happened to the other 63,500 addresses? Well, nothing. They just sat there, completely unused, but locked away so nobody else could have them.
The mismatch was just staggering. It was like needing enough space to build a garden shed, but being forced to buy an entire city block to do it. All that precious digital land was just locked up, and the internet was quickly running out of city blocks to hand out.
So, facing this huge address shortage, network engineers got creative. They came up with this really ingenious solution to take back all that wasted space. It was called Subnetter.
And the idea was totally revolutionary at the time, mostly because it just broke the rules. They basically asked, hey, what if we could just ignore that fixed line between the network and host parts of the address? What if we could take one of those giant, wasteful Class B blocks and just slice it and dice it into smaller, more useful pieces?
And here's how it works. It's pretty clever. You take your normal class-based address. Then, and this is the key part, you borrow a few bits from the front of the host ID section. And you use those borrowed bits to create a whole new section in the middle called the subnet ID. This creates a new, flexible dividing line.
What you end up with is this way more flexible three-part address. You still have your main network ID, but now you could create dozens or even hundreds of smaller subnetworks inside it, each with its own group of hosts. All that waste was suddenly gone.
Now you might be asking, how does a router know where this new, flexible line is drawn? Well, that's where the subnet mask comes in. It's another 32-bit number that works like a template or a filter. A router looks at the IP address through the subnet mask, and the mask tells it exactly which bits are for the network and which bits are for the host. It's the key that makes the whole thing work.
So, subnetting was a huge win. It solved the critical problem of running out of addresses. But as networks got bigger and more complicated, a totally different challenge started to pop up: just keeping things organized. So imagine, you've perfectly subnetted your company's network. It's super efficient. That's great. But what happens when your sales team is spread out across 3 different floors? Or the engineering department is in 2 separate buildings? Physically, they're on different networks. But for work, they need to act like they're all sitting in the same room.
And the solution for this problem is the virtual LAN, or VLAN. It's a way for network admins to use switches to group devices together based on what they do, not where they're physically plugged in. You can literally create a virtual sales network that links everyone on that team, no matter what floor they're on.
This is a game changer for organizing teams. It lets you group people by department, sales, engineering, you name it. And technically, it creates what's called a single broadcast domain. The best way to think about it is like a private intercom system. A message sent out on the sales VLAN only gets heard by the sales team. It completely ignores physical walls and connects only the people who need to be connected.
So, from the address crunch to the chaos of organization, these brilliant fixes, subnetting and VLANs, they were like genius hacks that extended the life of the Internet's original address system for decades. But it does leave us with one last big question for today's world. In an Internet with trillions of devices, what happens when even these clever fixes just aren't enough? But that's a story for another explainer.